All right, last time we crowned steel the undisputed king of mass engineering. So now we turn to the modern world to look at its shiny, lightweight challenger, aluminum. This is the metal that really promised to change everything, from the way we fly to the cars we drive. But the question is, does it really deserve a spot at the very top?
And that's exactly what we're here to figure out. No mercy, no free passes. Does the metal that makes so much of our modern world even possible, does it really have what it takes to join steel up in the S tier? Or is it just a specialist, destined to shine bright in its own little corner, but never truly dominate?
It always comes down to this comparison, doesn't it? On one side, you've got steel, dense, unbelievably strong, the absolute workhorse of the industrial age. And on the other, you have aluminum, the quick, agile contender that weighs in at about a third of its rival. It's a classic battle of brute strength versus speed and finesse.
And hey, don't think for a second this is just some old-school debate. This is happening right now. Just recently, the price of aluminum has been surging, all thanks to tight supply and massive demand from the green tech sector. This just proves that aluminum's story isn't over. In fact, it's more relevant today than maybe ever before.
So to really get a handle on its place today, we got to rewind the clock and look at its pretty remarkable journey. I mean, it's a story of a metal that went from being an emperor's treasure to the very stuff that lifts us up into the sky.
I mean, just let that sink in for a second. Back in the mid-1800s, aluminum was so rare, so incredibly hard to produce, that it was worth more than gold. Napoleon III knew this, and he used it as the ultimate flex, a status symbol that was a level above what he offered to his less important guests. Wild.
And from there, wow, its rise was just explosive. Discovered in 1825, it was basically just the lab curiosity until 1886. That's when the Hall-Héroult process finally cracked the code for making it cheap. The price plummeted. Then World War II comes along and makes it totally essential for aviation. And by 2015, it's so mainstream that it's being used for the body of America's best-selling truck. What a climb.
So what's in the secret sauce? What exactly makes this metal so special? What are those key properties that let it go from a novelty to a necessity? Let's open up the Champion's Toolkit and take a look.
First up, the one everyone knows, it is insanely light. At about 2.7 grams per cubic centimeter, it has roughly one-third the density of steel. Now for anything that needs to move, a car, a plane, you name it, slashing two-thirds of the weight is an absolute game changer.
But here's a superpower that's maybe even more important today. 95%. That's how much energy you save when you recycle aluminum versus making it from scratch. It can be recycled over and over and over again without losing any quality, which makes it a true cornerstone of any kind of sustainable circular economy.
And believe me, the list does not stop there. It's got an elite strength-to-weight ratio, especially when you mix it into alloys. It naturally creates this protective oxide layer, so it's super resistant to rust. It's a fantastic conductor of both heat and electricity, and you can shape it into almost anything, from super thin foil to complex car frames. It's a truly versatile piece of kit.
Okay, but we promised a no-mercy analysis, right? No material is perfect. Every champion has a weakness. And let me tell you, aluminum's is a big one. It's time to take a hard look at the cracks in that shiny armor.
And if you want to understand its biggest flaw, you just need to know these two words: solid electricity. Primary production, the process of making it from raw bauxite ore, is so incredibly energy intensive that economists and engineers literally call the metal itself solid electricity.
And this chart, wow, it really lays it all out there. Just look at the energy it takes to make 1 kilogram of new aluminum, about 15 kilowatt hours. That is more than double what you need for steel. You can see how much better recycling is, of course, but our growing demand still requires massive amounts of this brand new energy-guzzling metal.
So yeah, that huge energy cost, that's the main headline for its weaknesses. But it's not the only one. Its absolute strength, even in the best alloys, just can't match up with high-strength steels. It starts to soften at pretty low temperatures, around 200 degrees Celsius, so it's no good for things like engines. And it can be prone to fatigue, which means you have to be really careful when designing things like airplane wings.
So, there we have it. The incredible strengths and the significant flaws all laid bare. We've seen the evidence. Now, it's time to render the judgment. And you know the drill. To keep things fair and square, we're running it through our 6 standard criteria: historical impact, mechanical properties, workability, scalability and cost,
versatility, and of course, its lasting relevance in the world today.
All right, let's run the numbers. Historical impact gets a strong 8. I mean, it didn't define an entire age like iron did, but it absolutely enabled the age of flight. Mechanical properties also get an 8. That strength to weight is fantastic, but it's held back by its limits with heat and fatigue. Workability gets a stellar 9. It's just so easy to shape. Scalability and cost, though, takes a hit with a 7, and that's all about that massive energy footprint. Versatility is a very solid 8.5, and lasting relevance scores a big 9 thanks to its role in EVs and renewables. That brings us to a final average of 8.3 out of 10.
And an 8.3 average places aluminum firmly, and I think rightly, in the high A tier. It's an elite, incredibly important material, but it's just not quite an S tier universal dominator.
So what does high A tier actually mean in our book? It means aluminum is an essential specialist. It makes modern tech possible, things that literally couldn't exist without it. But it is ultimately held back from that top S-tier spot because of its energy cost and its inherent strength limits when you put it head-to-head with the raw power of steel. You know, here's maybe the best way to put it. If iron and steel are the foundation and the heavy frame of our industrial world, then aluminum is what gave that world wings. It doesn't replace the foundation, it builds on top of it, letting us all move faster, lighter, and way more efficiently.
And that leaves us with one final thought to chew on. Just look around you. The phone in your hand, the laptop on your desk, the airplanes flying way up overhead. Which of these modern marvels, these things we take for granted, simply could not exist without this lightweight challenger? The answer really shows you just how much we owe to this amazing high A-tier material.